Dear friends, students and learners, I'm Shashank Srivastava from School of Engineering and Technology, IGNOU. So before this session we were discussing about the VO Tribology surface treatment and coatings unit, and in that we have covered the part 1 of this particular unit, and now we will discuss the part 2, and after that will be the part 3, which will be the last part of this unit as well as of this course. So we are finishing this course today. So let's start with this. So first of all, we will discuss here what is tribology. So before this we have discussed about wear. Now we will see what is tribology. Actually, wear is a very major limiting factor in the life of any kind of machine as well as mechanism, and is due principally to what is called friction between surfaces that rub together. So wear is mainly because of the friction that is coming in between the surfaces which are in contact. Then another term came up which we are discussing right now, that is tribology. So this term was given to this theory and practice of contacting surfaces in relative motion. And why was this new name introduced? Actually, simply because the other terms in common use, such as the friction, wear and lubrication, refer to only one part of the technology of moving surfaces in contact, whereas tribology covers all, including the friction, the bearing design, the lubrication systems and wear as well. So that's why the tribology is more a generic name and it covers all the things. That's why we are using this term. And it is mainly concerned with machines and mechanisms, but there may be cases where surfaces rub together outside a machine also. So then first part of this tribology is the friction, which we will discuss right now. So friction, what is friction? You must have heard, it's a very common term in our daily lives, and it is the resistance to motion which is set up when one body slides over one another. Suppose my hand is there like this, so if these two hands, left and right, if they are rubbing together, so they can be considered as surfaces which are in contact with each other, and there will be friction between the two. So in every machine some energy is used to overcome friction at the workplace where surfaces slide over each other. And in order to reduce this friction, we use lubricants such as oil or grease between the surfaces. And due to this, energy loss becomes less, but it is never eliminated. Generally, then friction is very undesirable, wasteful form of energy. But in reality, there are situations in which friction plays a very important role. Like for example, if you are suppose driving or walking on a slippery surface or on a road after rain, then if friction is not there, then you can't stop. You will just go on slipping and it can be dangerous. You can go and collide somewhere. So what are the types of friction? There is the static friction and the dynamic friction. These are the basic two types, and under them there will be subheadings also. So when two bodies in contact actually do not move relative to each other but have the tendency to move, then friction is termed static. So in actual terms they are not moving, but they have a tendency that if they are rubbing against or moving relatively to each other, then there may be some movement. And if relative motion occurs, the bodies still experience friction force. And obviously if they are moving also, actually the force of the movement force has overcome the frictional force. That's why they are moving, but the frictional force still exists. It has not gone away, and this one is known as dynamic friction because of the movement. There are further classifications like the sliding and the rolling friction, and it is on the basis of the type of motion. Like if there is sliding motion, then it's called sliding friction. Otherwise, if there is a rolling, suppose there is a sphere or a ball which is rolling on the surface, then it's rolling friction. Friction between the lubricated and unlubricated surfaces, this is one more classification which is on the basis of the lubrication. So friction experienced between two dry and unlubricated surfaces in contact is also known as the dry or the solid friction. Suppose there is no lubrication, then quite obvious name, dry or solid friction, and it is due to surface roughness. And one more thing to note is that all surfaces, no matter how smooth they are, have irregularities at microscopic or molecular level. So there are certain irregularities. You cannot say that the surface is completely 100% smooth. In such a situation, when two surfaces are in contact, only peaks or the asperities will come in contact. Wherever the imperfections are there, if there are peaks, then they will come in contact, other part will not come in contact between the two surfaces. And such asperities will deform plastically due to concentrated load. Suppose there are peaks, and these peaks are between the two surfaces are coming in contact, and then you apply a load, suppose from the top on one of them, then these will deform, these peaks will deform plastically, and this plastic deformation will hinder the relative motion, because then it will try to stick to the other piece if there are two pieces, and thus friction will increase. The peaks may also insert into valleys. There may be some valleys also, like crests are there, troughs are there in a curve. So there may be valleys, and in that the peak may go inside, and it will make the relative motion more difficult and increase the friction more. So this is one kind of explanation of sliding and rolling friction. So what is the solution for avoiding this friction which is hampering the things? So there is oil film lubricant, which is introduced between the surfaces of contact, and if thin film of lubricant is just sufficient to fill the valleys, then they will reduce the load concentration on the asperities and result in less or no plastic deformation, and this will reduce the force of friction. And this type of lubrication is known as the boundary lubrication, because the film of lubrication is thin. And there can be another situation where a thick layer of lubricant is used between the rubbing surfaces, and this thick layer will actually not permit contact between asperities and the surfaces. In thin layer there may be certain contact, but in thick lubrication there is no contact between the two surfaces, and actually the surfaces are floating over the oil film, and the relative motion in the case of the thick film will be hindered by the viscosity of the lubricant. So viscosity is the term, and you must have read in fluid mechanics also, and through the viscosity this thick film lubrication is affected, and the viscosity plays a major role instead of the contact between the two surfaces, and this will effectively reduce the force of friction considerably, and this situation is known as the fluid or film friction. So in the figure also you can see how the asperities are there between the two surfaces. Then there is the boundary lubrication, and the boundary lubrication, the thickness of the oil film is less, whereas in case of the fluid film lubrication, or the thickness of this layer, lubricant layer, is more. So when we were discussing about friction, let's know about the laws of friction also. So frictional force is said to be proportional to normal force between the surfaces of contact. So suppose there are two surfaces which are in contact with each other. Now the force which will be acting perpendicular to the surfaces is known as the normal force, and to this normal force the frictional force is proportional, meaning it is dependent, directly dependent. And the force of friction, then the second point is that force of friction is independent of the apparent area of the contact. So this force of friction is actually not dependent on the surface area, the surfaces which are in contact with each other. This area of these surfaces doesn't affect the force of friction. So then we can say that F is directly proportional to R, where R is the normal force that is acting, and if we write it as a formula, as an expression, then it will be F equal to mu R, where mu is the constant of proportionality, and it is known as the coefficient of friction. And it depends upon what? It depends upon the nature of the contacted surface, how smooth it is, what kind of asperities are there, and it also depends upon the nature of lubricant in case of film or fluid lubrication. So when we want to reduce friction, we have seen that we use lubricants, and also let's discuss the lubricants in detail. So any substance which is introduced between two moving or sliding surfaces to reduce the frictional resistance between them is known as a lubricant. So whatever we are introducing between the two surfaces moving relatively to each other, that is a lubricant, and we want to prevent the friction. That is the relative motion should not get hindered. The main purpose of a lubricant is to keep the sliding or moving surfaces apart, as I have told already, so that the frictional resistance and consequent destruction of material is also minimized. And process of reducing frictional resistance between the moving or sliding surfaces by the introduction of lubricants in between is known as lubrication. So one was the lubricant, now is the process that is called lubrication. So what are the functions of a lubricant? It reduces surface deformation. We have seen that this plastic deformation is lessened, it becomes less. Then it also reduces wear and tear because the direct contact between the rubbing surfaces is not there. Then it reduces loss of energy. Obvious, it is because force of friction will cause some proportional loss of energy, and if it is reduced, the loss of energy will also reduce, and this loss of energy, which is in form of heat, becomes less, and efficiency of machine is also enhanced. And this lubricant then reduces the expansion of metal by local frictional heat. So any kind of deformation that may be happening in the metal because of the heat production due to the rubbing will now be less, because the lubricant will help us to avoid that. And it avoids seizure also. Seizure meaning the two things have got stuck with each other, like seizure happens in case of IC engines also, internal combustion engines. So this is prevented by the use of a lubricant. And maintenance and running costs, obviously if these things are there, energy loss is less, then the costs are reduced for maintenance and running. And lubricant also acts sometimes as a seal, meaning it will seal a gap or something like that, so that there is no leakage. Like for example, lubricant used between piston and the cylinder wall of an internal combustion engine acts as a seal, thereby preventing the leakage of gases. Actually the gases are produced inside that cylinder, they will not leak out under high pressure from the cylinder, and hence proper we will getting expansion stroke and power stroke. So what is the mechanism of these lubricants? How do they act actually? There are mainly three types of mechanism by which lubrication is done. One is the fluid film, thick film one, which is known as the viscous or hydrodynamic lubrication also. And we have seen it, this name also we have seen earlier also in the session. And boundary lubrication also we have read, or thin film lubrication. And the third one is the extreme pressure lubrication. So what is the fluid film or thick film or hydrodynamic lubrication? In this, the sliding surfaces are separated from each other by a thick film of fluid, so that direct surface to surface contact and the welding of junctions rarely occurs. So this is the thing happening. And the resistance to movement of sliding parts is only due to the internal resistance between the particles of the lubricant moving over each other. So the resistance is not due to the rubbing of the two surfaces, but due to the particles within the lubricant only. No other kind of resistance is there. And the lubricant chosen, that's why you should have the minimum viscosity, because if it is too viscous, then also the movement will be hindered under working conditions. And at the same time it should remain in place and separate. So two properties are needed, that it has to be not to be very high viscous, and it should also not be very light or very less viscous, such that the fluid flows away. So that should also not be the condition. And in such a system of hydrodynamic lubrication, the effective coefficient of friction actually depends on certain factors, which are like the viscosity, and the thickness of the lubricant, all are meaning you can understand very easily, because they are quite obvious. Viscosity of the fluid is very important, thickness of the lubricant also, then the third point is the relative viscosity, and the fourth one is the area of the sliding surfaces. And the coefficient of friction in such cases of hydrodynamic lubrication is as low as 0.001 to 0.05. So due to the use of this lubricant, the coefficient of friction is reduced to a very high extent. And what we are using in this actually hydrocarbon oils, like we have studied CH4 and all those bonds are there, they are considered to be satisfactory lubricants for fluid film lubrication. And in order to maintain viscosity of the oil in all seasons of years, ordinary hydrocarbon lubricants are blended with selected long chain polymers. You see, if in winter it may happen that due to the temperature change, the viscosity of the oil becomes quite high and it becomes very thick, and the movement is hindered. So in that case we will have to add certain things so that this fluidity, level of fluidity that we need is maintained. Then comes the second type of lubrication, that is the boundary lubrication or the thin film lubrication. So here a continuous film of lubricant, when it cannot be persisted and direct metal to metal contact is possible, then we have to use this thing. So this happens when a shaft starts moving from rest, or if the speed is very low and the load is very high, then the two surfaces may come in contact with each other, or the viscous force of the oil is too low, because then the fluid will flow away from in between the two surfaces. So all these four conditions can lead to this kind of lubrication need. So vegetable and animal oils and their soaps possess property of adsorption or surface attachment, either physically or yet chemically with metal surface, and thus they form a thin film of metallic soap which acts as a lubricant. Thus the load is carried by the two layers of the adsorbed lubricant. So animal and oil and soaps have this kind of property. For boundary lubrication, actually the lubricant molecules should have certain properties, like they should have the long hydrocarbon chain, then they should have polar groups to promote spreading over the metallic surfaces at high pressure. After that there should be lateral attraction between the chains, and active groups or atoms which can form chemical linkages with the metal or other surfaces is needed. So high viscosity, resistance to heat and oxidation, good oiliness and low pour point are some of the good characteristics of boundary lubricants. So after discussing the first two, the thick film lubrication and the thin film lubrication, we move on to extreme pressure type of lubrication, and why it is needed actually. So there are sliding surfaces which are under very high pressure and moving with high speed. So what will happen? A high local temperature is attained, and this further leads to lubricants which fail to stick, and so they may decompose and even vaporize. So that's why this type of lubrication is then needed in such conditions. So solution for this is like special additives are added to mineral oils, and these are called extreme pressure additives, and they form more durable films on metal surfaces which are capable of withstanding very high loads and high temperatures. So there are certain important additives like organic compounds which are having active radicals, like for example the chlorine radical or the sulfur or the phosphorus. So these are used in this case of extreme pressure lubricant, and these compounds react with metallic surfaces or at prevailing high temperatures to form metallic chlorides, sulfides and phosphates. So these metallic compounds possess high melting points and thus serve as good lubricant under extreme pressure and extreme temperature conditions. And if by any chance the low shear strength films are broken by the rubbing action of moving parts, they can be immediately replenished. So this was all about extreme pressure lubricants. So now the classification of lubricants on a different basis, that is on the basis of their physical state. Like they may be as liquid lubricants or lubricating oils, or they may be like semi-solid lubricants or greases or solid lubricants. So three types are there. So first of all, we discuss the lubricating oils. Lubricating oils actually reduce friction and wear between two sliding metallic surfaces by providing a continuous film between them, like we have seen earlier also, similar case. Then the lubricants also serve as coolant at the same time. So they are serving two purposes now, lubrication also and cooling also, as well as corrosion preventer and sealing agent. So sometimes these lubricants serve many purposes. A good lubricating oil thus must have a low vapor pressure or high boiling point and low freezing point. Why low vapor pressure? Because see, we need a high boiling point because otherwise this lubricant will go into vapor form. It will be highly volatile and it will be of no use, because we want a thin layer of liquid between the surfaces. So low vapor pressure means the tendency of this lubricant to go into vapor is lesser. So then we can use it as a thin liquid film. That's why we need low vapor pressure or high boiling point, and obviously low freezing point, because then it will be a solid. And it should be stable at high temperature, obviously, and should not oxidize or cause corrosion, because at high temperature, if it breaks down, then it cannot be used any further. Above all, a lubricant is required to be adequately viscous for particular application. We have seen this thing earlier also. Mineral oils blended with vegetable oils are generally used in practice. So we are using the combination of vegetable and mineral oil. And nowadays there are synthetic lubricating oils also, and they are manufactured for special purposes by bringing about change in the molecular structure. Special purposes are like under severe operating conditions, again temperature pressure conditions. So there are further subdivisions also in case of this lubricating oils. That is, the first one is the animal and vegetable oil. So before this petroleum industry came into existence, we were using these things, the animal and the vegetable one, and they have actually got very good oiliness. But there are certain drawbacks, like they are costly and undergo oxidation easily. And the product of the oxidation that is coming out is very gummy and acidic. So it will be sticking. Instead of providing lubrication, they will be increasing the friction. And these oils hydrolyze in moist air. So that is a drawback, because then they will have water inside also. And they are hardly used in machines except in blended oils. Then we have the mineral or the petroleum oils. So these are obtained by distillation of petroleum. We must have read in certain subjects, like in chemistry also, there is the fractional distillation of the petroleum. We get the petroleum products. So that is what is the petroleum oils. And the length of the hydrocarbon chain in petroleum oil actually varies between about 12 to 50 carbon atoms. So quite a lot of variation is there. And shorter chain oils have lower viscosity than the longer chain hydrocarbons, and these are most widely used because they are cheap and available in abundance. Like in case of animal and vegetable oils, they were said to be costly. But these also have drawbacks, like they are poor in oiliness. They are not as good as the vegetable or the animal oil. And but this oiliness, it is said, can be improved by adding high molecular weight compounds like the oleic and the stearic acid, and as well as the vegetable and oil and fatty acid that we discussed earlier. Then we have got the blended oils. So there are certain good properties, certain drawbacks also, so we can go for this blended type of things. Then the highly stressed modern machinery runs under conditions in which a straight mineral oil is not adequate. Yes, that is so we cannot simply say that I will use this animal or vegetable oil or either mineral oil. So we have to go for blended oil. And these additives actually have to be added, and they improve most of the properties of mineral oils in the same way as certain elements do for steel, like we alloy, certain alloys are there, we mix certain elements with the steel, so properties are improved. Similar is the case here. The so-called blended oils will give desired lubricating properties required for a particular machinery. So in this session we got to know about the friction, and we got to know about the term tribology, and then further we learnt about the lubrication, what is lubrication, and types of the lubrication. So all these things we have seen in this particular session, and we will further discuss in the next one. Thank you very much.